Okay, we'll look at some of the homework problems in section 3-3. We'll start with problem number 1, where you have to find each of the following. For each of the following, you want to find the whole number that would make the equation true. And we'll start up with part A in the problem. 3 times z is equal to 9. And you want to find out what z is going to be equal to. In this particular case, you have to find out what number z multiplied by 3 will give you an answer of 9. And the only answer for that would be 3. So z in this case will be equal to 3. Part B, in the problem 24 is equal to 12 plus 3 times z, we want to find out what z is. Okay, so in this case here, 3 times some number plus 12 will give you 24. Now you can solve this algebraically, you can use guess and check procedures here, but if you take the time here, if you multiply 4 times 3, you'll get the 12, plus this 12 will give you 24. So z will have to be 4. Now again, you can solve this algebraically. It's just like an algebraic equation. And in part C, in the problem, z times parentheses 3 plus 4, that's equal to z times 3 plus z times 4. We want to find out what z is. And if it's all real numbers, we'll type in R. In this case, it will be the set of all real numbers, because any number z will satisfy this particular situation. There's 3 plus 4, that'll be 7 times z, but really, any real number will satisfy that particular equation. Okay, let's look at problem number 2. We want to determine which of the following sets are closed under multiplication. And some of these are true-false. Like 0, 10 is closed under multiplication. Anything closed under multiplication means this: the product of any two numbers must be within that set. And for 0, 10, let's say if I do 10 times itself, 10 times 10, that's 100. 100 is not in this set. So the set 0, 10 being closed under multiplication would be false. Part B, 0 is closed under multiplication. Well, 0 times itself is 0, and it's in that set, so that would be true. Part C, 5, 10, 15, and so on is closed under multiplication. Well, if I do 5 times 10, that's 50. 50 is in that set. So this will be true. Keep in mind that the 3 dots represent that this set continues on and on and on. This is what we call an infinite set. Part D, 5, 7, 9, 11 is closed under multiplication. Let's see here. If I do 5 times 7, that would give me 35, and 35 would be in that set. 7 times 11 is 77. That too is in that set, so that would be true, that this set is closed under multiplication. And then 0, 1, 5 is closed under multiplication. Well, 0 times 1 is 0, so that's 0 is in that set. 1 times 5 is 5, that's in that set. But if I do 5 times 5, that's 25. 25 is not in that set, so 0, 1, 5 being closed under multiplication would be false. Okay, take a look at problem number 3. Let's say we want to place the parentheses if needed to make the following equations true. And in this first one, we have 4 plus 3 plus 2, and we want that equal to 14. And we want to place the parentheses around numbers. Well, we know if we left it as is, 3 times 2 would give us 6 plus the 4, which is 10, which is not equal to 14. But if I place the parentheses around the 4 and the 3, then that would work, because 4 plus 3 is 7. 7 times 2 would give me 14. So that would have to be answer B. All right, now what about for this one? 6 divided by 2 plus 1 is equal to 4. Well, if I place the parentheses around the 6 and the 2, I'll have 6 divided by 2, which is 3, plus 1 is equal to 4. But really, I don't need the parentheses here. The reason for that is, by order of operations, it will automatically do the division first, and then the addition. So this will be answer B, because this can be done without the use of parentheses. Part C. Let's say we want to choose the correct solution for 5 plus 4 plus 9 divided by 9 equaling to 2. In this case here, this may be a little bit difficult here because let's say we place the parentheses here. Add 5 plus 4, that's 9, plus 9, that's 18. 18 divided by that 9 will be 2. Okay, so the parentheses around the 5 plus 4 plus 9 would work, which is answer D. And E, let's say we want to place the parentheses around the 5 plus 6 divided by 2 plus 2 is equal to 10. In this case here, we probably don't need to, because if we do 6 divided by 2, that's going to give us 3, and then 5 plus 3 will be 8, 8 plus that 2 will be 10. So actually, this will be answer B. So this one does not need the parentheses. Okay. Number 4 is to solve this particular equation. Q is equal to 280 divided by 5. Now here we can do long division here by dividing 5 into 280. And then we divide 5 into 28, which will go 5 times. And then 5 times 5, that's 25. Subtract 25 from the 28, you'll get 3. Bring down the 0. 5 goes into 36 times. Then 5 times 6 would be 30. Your remainder is 0. So 56 would be the solution, or what the value of Q is going to be for 280 divided by 5. Okay, problem number 5. A popular brand of pen is available in 15 colors and 4 writing tips. How many different choices of pens do you have with this brand? And they tell you to use the fundamental counting principle with 2 groups of items. And in this case here, we have 15 colors, 4 writing tips. So using the fundamental counting principle, we'll do 15 times 4, which is 60. So that means that there are 60 different choices of pens for this popular brand. And all I did was use the fundamental counting principle to solve this particular problem. Number 6, decide whether the equality is an example of the commutative, associative, or distributive property. In this case here, we got 6 times parentheses 7 times 42, and that's equal to parentheses 6 times 7 times 42. In this case here, notice that the grouping is different. The order is the same, but notice the grouping, the print around the parentheses of those numbers is different. So that means this would represent the associative property of multiplication, as we're dealing with multiplication in this problem anyway. All right, number 7, the distributive property of multiplication over subtraction is this. A parentheses B minus C is equal to A times B minus A times C. Now what you want to do is use this property to find each of the following. In part A, you get 8 times 9 minus 6. So if I use this property, this will be 8 times 9 minus 8 times 6. I'm just distributing the 8 over the 9 and the 6 using subtraction. Using multiplication. 8 times 9, that's 72. And 8 times 6 is 48. So now you got 72 minus 48, which is going to be 24. So here, 8 times 9 minus 6 will give you an answer of 24. And then part B is done the same way. Distribute the 40 over the 7 and the 6. So now you have 40 times 7 minus 40 times 6. Well, 40 times 7 is 280 minus 40 times 6, that's 240. And then 240 from 280 will give you 40. So 40 times parentheses 7 minus 6 will give you 40 as an answer. Okay, next is to write a related multiplication sentence. You got 48 divided by 8 is equal to 6, and we want to write a related multiplication sentence. Well, one related multiplication sentence would be this: 8 times 6 equal 48. Or you could say 6 times 8 is equal to 48. Either way, that would satisfy the related multiplication sentence because of the distributive property. Okay. All right, problem number 9. Well, we have a bag that can hold 16 kilograms of sand. How many bags can be filled with 984 kilograms of sand? How many kilograms of sand will be left over? This one will be a division problem. So we're going to divide 16 into 984. So here we want to find out how many times 16 goes into 98. Because we know 16 can't go into 9, but 16 can go into 98 6 times. So if you multiply 6 times 16, that will be 96. And then 96 from 98 will give you the 2. Bring down the 4. And then divide 16 into 24. That's going to go 1 time. So that means 1 times 16 is 16. 16 from the 24 will give you 8. And 8 is less than our divisor 16, so that means the number of bags that we need to use is 16. But we're going to have 8 kilograms of sand left over. And sometimes we write that as 61, remainder 8. All right, number 10. A designer has designed different tops, pants, and jackets to create outfits. How many different outfits can the models wear if she's designed the following pieces? 2 tops, 4 pants, 6 jackets. 2 tops, 4 pants, 6 jackets. 7 jackets. Well, we use the fundamental counting principle. That's 2 times 4 times 7. Well, 2 times 4, that's 8. 8 times 7 is 56. So here we got 56 total of 56 different outfits that the models can wear. So we just use the fundamental counting principle for this particular problem. All right, number 11. Find the equivalent expression using the distributive law. We got 9 times parentheses b minus c minus d. Well, when we use the distributive law, we're just distributing the 9 with the b, the c, and the d through multiplication. So 9 times b will be 9b minus 9 times c, which is 9c, minus 9 times d, which is 9d. So you'll end up having as an answer 9b minus 9c minus 9d. And then finally, number 12 is to place the parentheses if needed to make the following equations true. And in this case here, we got 4 plus 3 times 3 equals to 21. And I believe you've seen this before. Place the parentheses around the 4 and the 3. Because 4 plus 3, that's 7 times the 3, will give you the 21. Choose the correct solution for 9 divided by 3 plus 1. Well, if I place the parentheses around the 9 and the 3, around 9 divided by 3, 9 divided by 3 is 3 plus 1, which will give you 4. Again, I don't need the parentheses because order of operations will tell us to do the division first and then add 1. And this one, if we want that to be a 2, parentheses around the 5 plus 4 plus 9, that would give you 18 divided by 9, which would give you 2. That would be this answer. And then finally, 5 plus 6 divided by 2 plus 3 equals to 11. If we want that to be 11, if we do 6 divided by 2, that's 3. 5 plus 3 is 8 plus 3 is 11. So we can do without the parentheses there. Okay. And that should be, I got one more. Decide whether the equality is an example of the commutative, associative, or distributive property. We got 8 times parentheses 2 times 16, and that's equal to parentheses 8 times 2 plus 16. This would be the associative. Notice the grouping around the 2 and the 16 and the 8 and the 2. Those were different. So that would be the associative property. So this should assist you with the homework problems that are on the MyMathLab.